All right. Hi, everyone, and welcome to my talk. Several components are rendering. Client performance at Slack scale. As you said, my name is Jenna Zeigen, and, well, I used to be a senior staff software engineer on Slack's client performance infrastructure team. I started at Slack in 2018 on the search team, actually, where it quickly became my thing to make Slack's desktop autocomplete experience the one y'all know and love today. Well, I've had the performance bug since very early on in my career. It was on that team where I really started to cut my teeth doing JavaScript runtime performance work, and by early 2021, I was working on Slack's front-end performance full-time, eventually founding our client performance infrastructure team. 2 weeks ago, I joined Notion to do very much the same thing, to make Notion fast. And I'm excited to tell you the story about how we did that at Slack. But first, I realized I've been giving talks for 10 years, which is wild. My first conference talk was JSConf EU, September of 2014. So giving talks is an amazing opportunity, which is why I'm up here again. I love meeting people and getting to hear stories about engineering and management. All right, but we are here to hear a story about performance. And I know this is lead dev. A lot of you are managers. We're talking about computers, computer performance, not, that type of performance. So as a way of introduction, I'm going to tell you a little bit about Slack's desktop app, some of which you might already know. Slack, I'm sure many of you use it. At its core is a channel-based collaboration tool. There's a lot of text, but there's also a lot of images, files, and video conferencing. Also, as some of you probably know, the Slack desktop isn't native. It's an Electron app, which means it is a web application being rendered by a Chromium instance, and it uses React, which ultimately means we're using good old HTML, CSS, and JavaScript, just like any old web application inside of a canonical browser like Chrome, Safari, Firefox, Arc. This means that we're subject to the same performance constraints and challenges presented by browsers. But Slack is also a little bit different than many web applications and web pages you're used to. I don't know about you, but my Slack is open for days, if not weeks, and I only restart it if I absolutely have to. So Slack desktop sessions are very, very long-lived. And they're also very active, right? Especially in large workspaces. You're typing messages, your coworkers are typing messages. There's reacties and GIFs and huddles. So WebSocket events and other API calls and user interaction, that's constantly coming in, and we have to process it and react to it by updating the app to show you, because if you don't see your coworkers' messages, then what's the point of Slack, right? So this means that the browser is doing a lot of rendering. So what exactly is the browser doing to show you your coworkers' messages, right? So we're going to talk about browsers, right? So one of the many jobs of a browser is to convert the code that we send it over the wire into pixels on the page. It does this by creating some trees and turning those trees into a different tree. And then the browser is going to take that final tree and it's going to go through 3 more phases. And then it has to do this every single time the DOM updates. So every single time there's an update, it has to do a whole lot of work. So the browser, at its best, is going to try and do this 60 times per second, provided there's something to update. So 60 times per second, 60 frames per second, that is 16.666 milliseconds. We call this an animation frame. And this is a magic number in the performance world. But wait, there's more. It's 2024, so there's a whole lot of JavaScript we have to do too. JavaScript is single-threaded, running on the browser's main thread along with all the other browser's responsibilities that we just talked about. But if there's any JavaScript left to execute, those renders can't happen, and you end up with dropped frames, jank, and lag. So just to kind of emphasize this means that we as front ends have a teensy 16 millisecond budget for doing this important work. But another note about front-end performance. A few years ago, I was reading this book, and I quote, In my experience, the application is rarely re-engineered unless the inefficiency is egregious and the fix is easy and obvious. The alternative presented here was to move the code to a faster machine or split the code over several machines. Let's just throw some money at it, right? This is simply a non-starter for front end, right? Unlike on the back end, we don't have control over the computers our code is running on. People can have anything from a souped up, what are we on now, M3 Max, all the way down to a 2-core machine with who knows what other corporate spyware is running on that computer, competing for resources. So yeah, this is just the way it is. But we still have to get our software to perform well no matter what. And that's part of the challenge or the terror of front-end performance, because we owe it to our users to give them a great experience performance-wise. Which brings us to this question: why do we do performance anyway? Like, why do we perform performance? It's easy to get bogged down in this, like, making the graphs go in the right direction. Lower number of milliseconds. Is it about making more money? Is it so that people don't write bad things about you on Hacker News? I'd argue that, well, it's like, I used to say, oh, we do performance so our users can have a great experience. But ultimately, it's about, like, getting out of our user's way, right? As soon as the user notices the performance of the application, then it is too late. Your performance is bad. I used to joke when I was working on autocomplete that I did a lot of work to keep the performance of the feature acceptable as we kept adding more and more to the ranking model, which we did client side, by the way. So that was a lot of JavaScript to do in under 100 milliseconds. So yeah, ultimately, we just want the user experience to be fine. But circa 2021, our users were not having a fine experience. We knew something was wrong because we were hearing about it from users in surveys and customer support tickets, not to mention on social media, Hacker News posts, oh, Electron is slow. Regardless, we knew we needed to do something to make it better. But as I said, I was the first person to be working full-time on front-end performance. So I got into this. Initially, I pitched front-end performance regression testing as part of a larger initiative to help us answer the question, what do we want our front-end code base to look like in 2022? I was like, okay, we should probably have some type of performance thing going on. But we quickly realized that regression testing wasn't what we needed because our problems were paper cuts, not catastrophes. And we weren't going to catch these types of performance issues with the canonical regression testing. What do I mean by paper cuts, right? I mean it in this death by 1,000 cuts way. So the classic performance story is you profile, you find the worst offending function, rinse, repeat until your app is faster. But this is what we ended up with, right? If you're discerning, you might say, well, those gold things look pretty bad, and then there's that purple one. Right? Well, gold is garbage collections, and the purple is the browser doing a style recalculation. So, okay, maybe there's like a few things that we can do here. Reduce memory pressure, always good to do that. And okay, yeah, maybe we should change whatever thing made the browser need to like recompute the world. But other than that, like, what else do we do? Like, what do we optimize here? What can we do to remove the bulk from this? What is even going wrong? Right, so we pivoted fairly quickly to front-end performance observability. We needed to get a better handle on what even was happening here. And then down the line, once this initiative proved its value, proved that we were gaining traction with this, it became a real solidified team, client performance infrastructure in the observability and performance pillar, which also came about when the team was created. All right, so observability, out of that you get metrics. So we needed to devise metrics that were going to suit our needs. We tried to thread this needle between showing what was slow, actionably for engineers, to show us what's going on with their systems and make it movable, right? If people are going to put in work to fix performance, we kind of want to see the effort there. But also, we needed metrics that were going to demonstrate impacts on users from a strategic standpoint that would allow us to garner buy-in from other engineering and product leaders across the company. Input delay, key press lag, ended up being our flagship metric that showed up at the OKR level on the engineering, product, and design top-level goals for quarters and quarters to come. So that was really cool to see us start to gain that traction with engineering leadership there. But how do we make this better, right? Having the numbers are all well and good, but this is about user experience. So we realized quickly that to understand how the system was scaling and breaking, we needed a deeper understanding of the libraries and how they worked under the hood. It's enticing to keep profiling, fishing for performance gold. Maybe I will find some really long-running JavaScript this time, right? But really what we needed to do was understand the system a bit better to understand how it was breaking down. This was just done through a lot of good old-fashioned reading the docs and reading the code. So I'll share a little bit about what I learned. I'm sure many of you are familiar with React, or at least heard of it, but for good measure. React is a popular, well-maintained, easy-to-use component-based UI framework that promotes modularity. It's used across a wide variety of applications, from toy apps to enterprise software like Slack, because it allows you to iterate and scale quickly. Popularity means that it's well documented and there's solid developer tooling. 7 or however many years ago, when Slack chose React, it was the thing to choose, and it still remains very, very popular. It is often still the thing that companies choose to build their applications. Another key part about React is that components get their data from parent components, passed down as props, or they store their data in component state. And then when one of these props or state changes, the component is going to re-render. This type of state management doesn't really work at a sufficient scale, so then you bolt on a state management system like Redux, which provides you with a central data store. This makes sense when you have many components that need to know information about, say, channels or users, because it allows you to easily store that in a central location and then wire up your components to read information out of it, in this case via functions called selectors. This is Slack. I know you might not recognize it, but it is. There's Redux, the central data store, and a whole bunch of connected components. So what's going to happen is Redux is going to get updated due to an API call, WebSocket event, user interaction, or whatever. And then it is going to send out this bat signal, a subscriber notification, to every connected component that says, I've changed, which means that all of the connected components are going to recalculate their connected props to see if any values have changed, and then components with changed props are going to re-render. You might start to see where this doesn't scale well, but every change to Redux results in a notification firing. Every Redux notification means that all of the selectors are running. Every component that is connected is going to spend time running selectors, which is too much time. And then we're spending too long re-rendering components, often unnecessarily, because humans don't write perfect code. And we did see this in the metrics. Unsurprisingly, more than 50% of the time, we were not hitting that 16 millisecond animation framework, which meant that we were dropping frames and blocking inputs. And P99, so 1% of the time, we were above 200 milliseconds, which is, frankly, unacceptable. This brings us to the big question. What do you do, right? Do we keep React and Redux? If it's this architecture that is causing us to have performance problems, then do we replace it? So we took a step back, said, OK, what do we need from a state management system if it's not Redux? The main thing that we wanted was finer-grained subscription. If something in the channel state updated, only components that care about channel state should be re-rendering, right? So there are some out-of-the-box options, but they just didn't suit our needs. We also didn't really want to do a total rewrite. That would not be great. So finer-grained subscription was the thing that we really needed. But then there's also the flip side. keeping React and Redux. So React and Redux enabled our ever-growing team to build features with confidence, modularity, and velocity. We chose a system that was popular and people-friendly and allowed our engineers to remain agnostic of the internals of the system. And this worked for a bit, but yeah, it started to break down at scale as we pushed the limits. These problems were systemic and architectural. So we could either change the architecture or we could put in the time to fix this with mitigation and education and guardrails. So ultimately, was the cost of drastically changing our architecture worth it for the performance boosts? So sure, we could put in all our efforts to evaluating other frameworks, choosing another framework, or writing our own thing that solves the problems that we have. But this would be a multi-year project for the whole team, and there was frankly no silver bullet out there. We had over 200 front ends, so changing everything would be a huge lift. Redux, like many things, had trade-offs. It preferred consistency and approachability over performance. And other architectures just make different trade-offs, right? And we can't be sure how anything else would break down at scale either. So this was my take. My take was sticking to what we had. I thought it would be a viable path, and it had to be, at least for the short term. We understood the classes of problems that Redux was presenting us with and how to fix them. And the solutions, like every paper cut fixing it, it's not a super challenging pile of solutions. It was just that there was a lot of paper cuts, and it was this diffuse problem, right? So how do we go about solving a diffuse problem? Especially when every day we're adding to the pile of paper cuts. So even if we were going to write a new state management system tomorrow, it would take time to adopt, and our customers needed a solution today. As an engineer, especially as a senior engineer, it's really enticing to immediately think that a radical technical solution is the right solution to any problem of sufficient size. But I wasn't content with putting our eggs in a basket that wasn't happening. Here's a little kicker, though. The client performance infrastructure team was only 2 people. We are both fairly senior, but still 2 people is 2 people. So we needed to figure out how to scale ourselves, which is luckily part of the whole staff plus thing. We were able to quickly assemble a close circle of senior engineers from closely affiliated client infrastructure pillar. That was the easy part. The next, concentric circle of people was a little bit harder. We needed to figure out how to get other engineers on board, not to mention the engineering managers, PMs, TPMs, and everyone else who they worked with. So I decided to lean hard into creating a performance culture through education, tooling, and evangelism. And it stemmed from this. Engineers fundamentally want to create performance software, so let's give them the tools to set them up for success. Engineers naturally want to write performant code and just find performance important at face value. We had already found performance champions outside of the circles we already had alliances with, and in general, engineers were in fact eager to learn about performance and fix performance bugs. They just didn't really understand the system like I did. I'd taken a lot of time to really dig in and understand React and Redux. So I needed to take the time to teach what I learned to my fellow front-end engineers. There was a lot of writing posts, performance memos, if you will, as well as giving internal talks, pairing with teams, etc. React and Redux abstract away the internals, and that is a benefit of it most of the time. Some of you now probably know more about React and Redux than folks that use it every day, but that's through no fault of their own, honestly, right? But I'll keep saying it. It's important to understand the architectural context of the work we're doing, because these issues, well, didn't just fall out of the virtual DOM tree. So education is well and good, but teams aren't going to write performant code overnight just by understanding the system. We're humans after all, right? So to scale ourselves, we implemented guardrails that surface inefficiencies in code throughout the development process, making people aware of the issues to see when they were adding code that wasn't as performant as it could be throughout the development process. was the first step in making sure that these performance paper cuts didn't compound. But, all right, now that engineers know that they've written not performant code, they need a way to fix it. So we also provided them with a toolbox of little things that they could add. Use this React hook instead of that one. Use this constant that's going to be stable, and this would help to stem unnecessary re-renders. But sometimes you just need a good burn down chart to motivate people and say, hey, your team has the most lint warnings. You might want to fix that. You don't want to be the worst. So this involved a bunch of SQL, but it also involved working with folks on teams to sort out code ownership. And it involved being a performance influencer, bringing folks on board to push the program forward within their teams. It involved working with teams very frequently to fix their issues. There was a lot of rolling up to some SQL channels and being like, hey, pals, I noticed this component was the topmost re-rendery component yesterday. Here's why, and here's how to fix it. Let me know if you want to pair. And then empathetically working with them so that next time they will know how to spot, fix, and prevent new performance paper cuts from adding to the pile. And this was effective. It worked. Yep, I think that's some pretty solid progress. Those are some pretty good numbers, I'd say. So this brings me to an observation that I've made over the course of my career. Performance is often built up as this arcane discipline. You have your performance engineers, and they do performance, and everyone else does other things that, building the product, doing other infrastructure stuff. But we're doing ourselves a disservice by keeping performance an inaccessible discipline. I think this story shows that you can solve these large problems of performance at scale by creating a distributed solution, by using engineers across the organization, a distributed solution for a problem of scale. Crux slide here. Your performance culture cannot be a hero culture if you want it to scale. All right, this seems like that final conclusion slide that you all take pictures of, intending posting on Slack or on social media, but you never do. But there's more to the story. We figured out finer grain subscription. Our finest JavaScript engineers wrote some JavaScript, and we were able to take a giant chunk out of that pile of paper cuts. Those are some pretty stunning graphs, right? And 30% improvement to Redux loop times, no longer offending the animation frame. That's where my story ends at Slack, but I'm still processing it, right? Writing this talk has forced me to process feelings about the story, both as a human who poured their work soul and career growth story into this, and as an engineering leader. It's easy to speed to the end and say, oh, hindsight is 2020. Now you know that you could, in fact, fix Redux. And in moments of anxiety, I've had this very thought, oh no, all of that work that I did was a waste because Redux, they fixed it. As I mentioned at the top of the talk, I've recently started at Notion in a very similar role, making Notion fast. And I've realized that this is a great lens with which to interrogate my personal takeaways from this saga. That question, what would you do if you could do it again? It's not hypothetical to me, right? So I know with clarity what my answer is. I would, and I am going to put in the work to understand what the systemic issues are that are at play that are causing Notion's performance woes. And I'm going to work with my new engineering manager colleagues and the other tech leads to build a performance culture there too. I realize, and I'm maybe close to actually internalizing, that we could not have had the ending to this story that Redux fixed if we didn't have everything that was before it. It was the effort that we put in building a performance culture that created the matrix that encouraged and gave space to those amazing JavaScript engineers who were able to finagle fixing Redux. Without all of the work to deeply understand the system and understand how it was breaking down, we would not have realized exactly what we needed to do to make it better. To many, this is a success story, right? I heard some cheering, and in many ways it is. But also, I think this ending is like a little bit of a tragedy. It's not tragic that we spent all of that time only to find the silver bullet, but rather that this story ends with just that type of an act of arcane performance heroism that threatens scalable performance culture. And now the engineers at Slack, they no longer have the need to understand the system as deeply as they did before. And I can only hope, I'm not there anymore, I can only hope that the knowledge and culture doesn't decay. If only because performance issues and even architectures come and go, but culture is sticky. And I, like many of you, still use Slack every day, and I don't want it to get in my way. I want to have an acceptable time using Slack. Yep. All right, so thank you, audience. Thank you to LeadDev for having me, to David for being an excellent host and sitting with me last night to help me process my complicated feelings on this story. And thanks to my many former and current coworkers who gave me feedback on my slides and who pushed me to be a better speaker and storyteller. All right, thanks again.